Today we will learn about transformations of graphs. We begin with the function f of x equals absolute value of x, whose graph we know. But before we knew the graph, we made a table to determine what the graph looked like. You know the story. Choose values for x, then plug them into the function to get the corresponding y value, plot those points to see the shape of the graph. Now what happens to the graph if we tweak the starting function? For reference, I've included the graph and table for our starting function y equals absolute value of x. The tweak I want to discuss first is y equals absolute value of x plus 2. What does the graph look like? Well, if we look back at our table, the plus 2 just adds 2 to all of the y values. This change causes the graph to shift up 2 units along the y-axis. This is because all of the y values were increased by 2. Notice that the change plus 2 occurred outside the function because plus 2 was outside the absolute value. And a change outside the function affects the output and is therefore noticed along the y-axis. Next, we will attempt to graph the function y equals absolute value of x minus 3. Again, we have the original function on the left. And in this case, the change to the function, which we're going to call a transformation, affects the input because it occurs inside the absolute value function. And a change to the input will be noticed along the x-axis. Now this transformation is more tricky than the last one, so it may be helpful to ask yourself, what x values do I need to plug in to get the same y values I had with the starting function? Let's answer this question with a table. We'll keep the output values the same and then determine what numbers we must plug in for x. Let's start easy and ask what we need to plug into x into our new function y equals absolute value x minus 3 in order to get 0 inside the absolute value. Of course, plugging in 3 for x does the trick. Next, what do we have to plug into absolute value x minus 3 to get 1 in the absolute value? Well, that'd be 4 for x. And just keep asking yourself this same question as you go along. And then we can work it the other direction as well to complete the table. We have to plug in 2 for x in our new function to get negative 1 inside the absolute value, and so on. Plot these points to determine the graph. And you will notice that the graph shifted to the right 3 units because we had to plug in x values which were larger by 3 to obtain the original y values. Moving on, we will graph the function y equals negative 2 times the absolute value of x. In this case, multiplication by negative 2 is a transformation that will affect the output because it occurs outside of the absolute value function. And therefore, changes will be noticed along the y-axis. If we go to our table, we simply multiply all of the original y values by negative 2. And then plot these points to find the graph. Multiplying the output by negative 2 does 2 things. First, it stretches the graph vertically, meaning away from the x-axis by a factor of 2, because we doubled all of the y values. Second, it flips the graph vertically, meaning over the x-axis, and this is because of the negative sign. Finally, we will graph the function y equals absolute value of 1/2 x. Remember that a transformation is just an alteration of the starting function, and this transformation is inside the absolute value function, which means it affects the input. We will notice the change along the x-axis. As with our last input transformation, we keep the y values the same and then try to figure out what we would have to plug in for x. Let's start easy. In order to get 0 inside the absolute value, we must plug in 0 for x in our function y equals absolute value of 1/2 x. Next, what do we have to plug in to absolute value 1/2 x in order to get 1 in the absolute value? And that would be 2 for x this time. Then ask, how do we get 2 in the absolute value? Plug in 4 for x. To complete our table, we just ask what number we plug into absolute value 1/2 x to get -1 inside the absolute value. That would be -2 for x, and so on. Plot these points to determine the graph. You will see that the absolute value graph was stretched horizontally, meaning away from the y-axis by a factor of 2, because we had to plug in x values which were double the original in order to obtain the same y values.